Okay, so we're looking at functions. Let's look at so here's a situation. A distance that a motorcycle travels from an intersection in miles is a function of the time elapsed since leaving the intersection in minutes. Okay? Let's name this relationship G. Okay? So I'm going to put something on the screen, and I want you just to react to it and be honest. What are your thoughts? What is your reaction to it? What does it mean? Share it with the person next to you. Ready? Okay? So, what comes to mind when you see that? What does that mean? What comes to mind? All right? Go. Talk to the person next to you. Okay. So whatever your reaction was, here's what we want to move towards. Okay? So here's what we want to move towards when we see an expression like this. We want to conceive it as three things in harmony, okay? So first and foremost, the whole thing, what is it? This is the value of the dependent variable. And here, for this, it's a number of miles. It's a number of miles. So when you see that, knowing that the number of miles is a function of the number of minutes elapsed, and that thing is a number of miles. It's the value of the dependent variable. Okay? Of a function whose name is g, when the independent variable has a value of 8.3, and this, in this case, a number of minutes, 8.3 minutes. So the whole thing is the distance of the motorcycle from the intersection. When you see that thing, that is a distance that the motorcycle is from the intersection. Which specific distance is it? Which specific distance is it of the motorcycle from the intersection?
After 8.3 minutes.
When 8.3 minutes has gone by. At the moment in time, 8.3 minutes since leaving the intersection. Okay? Now, you don't have a rule for G, so we just leave it at that. Okay? Leave it at that. Questions on that? So function notation gives the value of the dependent variable when the independent variable is this value right here. In this case, it's a number of miles when the independent variable is 8.3 minutes. Okay, do it again. Ready? So there's this function. It's defined as f of x equals 3x squared plus 8x minus 17. So I'm going to put something on the screen, and I want you to react to it. Be honest. What comes to your mind? What do you think when you see this? Go. Go. So I think first. Take 10 seconds to think, and then talk. Okay. How many people did not do any computation or arithmetic? Congratulations. This is the value of the dependent variable of a function whose name is f when the independent variable has a value of 2. That's what that is. Do you have to do any arithmetic for that to have its meaning? No. You don't have to do any plugging in and computing anything. That thing is the value of the dependent variable for this function f when the independent variable has a value of 2. First and foremost. Okay? First and foremost. Now, yes, given the function definition, you're able to find out what that value is. But you don't have to find out the value in order for that to have its meaning. Okay? So, this is not telling you to do something. That's probably what many of you have been trained in this arena of functions in your pre-calculus and algebra, that this is telling you to do something. Okay? It's not a command to do something. It's a meaning. It's a value of the dependent quantity. And we can use f of 2 just like that, and it holds that meaning. Okay? Now, yes, we can find it, and many of you did. What is it? It's 11. Okay? So what is the value of the dependent variable when the independent variable has a value of 2? It's 11. And you get that by substituting 2 in everywhere there's an x in the rule and evaluating. Okay? So the meaning is not 11. Okay? The meaning is the value of the dependent variable when the independent variable has a value of 2. And in this case, we can find that. It's a value of 11. Okay, does it make sense? So, is this the same or different than the previous slide about the motorcycle? Exactly the same thing. Exactly the same thing. We want to train ourselves that when we see function notation, boom, that's the value of the dependent variable. It's the value of the dependent variable. And then sometimes we'll compute it and get a number and use that number. Sometimes we won't. We'll just use this. Okay, we could just use that. Using it as what it means. Okay? All right, so let's practice. Is it big enough to read in the back?
No.
Let's regroup here. Okay, so if d is a function of t, that expression will always be dependent is a function of independent, right? So to say something is a function of something means it depends on that second thing, right? The first thing depends on the second. So that means the first is dependent and the second is independent. So just think about how you use that language. How I feel on Saturday morning is a function of what I do on Friday night.
Yeah.
Okay? So what is dependent? How I feel on Saturday morning is a function of my activities on Friday night. Okay? So dependent is Saturday morning. That comes first. Dependent is a function of independent. Okay? So then, if the function name is w, representing the distance in any number of seconds t is just w of t. W of t, that is our dependent quantity for a given independent value t. So w of t. Okay? So what's the distance traveled by the car in the first 9 seconds? That's an easy one. Should have been. W of 9. It's just asking for a value of the dependent quantity, okay? Now, the car's change in distance in the third 2-second time interval. So I put I put 2-second time intervals here to help you. So this is the third, from t equals 4 to t equals 6. You see that? From 0 to 2 would be the first, 2 to 4 would be the second. So 4 to 6 would be the third 2-second time interval. So how do we get the change in distance over that time? 6 minus 4? W6 minus, or W of 6 minus W of 4. W of 6 minus W of 4. Why? Because the change in a quantity is the final value of the quantity minus the initial value of the quantity. So can I just do W2? 6 minus 4 is 2, so W2, right? What does W2 mean? What does that mean? The distance after 2 seconds, or in the first 2 seconds. That likely will be, very likely be different than the change in distance from 4 to 6. So there's a slight chance that they might be the same value, but as far as meanings, as far as the meaning of those two expressions, they are not the same. And if you want the change from 4 to 6 seconds, you need W6 minus W2. So don't do this. Is a common mistake students make. Don't do that. Okay, the distance traveled by the car from t equals 2 to t equals 5 seconds. Same idea here, even easier. W5 minus W2, which is different than W3. W3 is, W of 3 is incorrect. Okay? The change in distance over any second time interval beginning at time t equals x. Now this is harder. Okay? So looking at this, what was our beginning time here in the previous one? When's our beginning time? Time 2, right? So then we start, then what's our beginning distance here? Okay? So it's going to be minus W of x. And so we want the change in distance over a 7-second time interval. So what's the final value of time going to be 7 seconds later? X plus 7. So if we're starting at time x, 7 seconds later will be x plus 7. So to get that change in time over any 7-second interval starting at time x, you're going to do Wx plus 7 minus Wx. Make sure that makes sense. If you're hazy on that, make sure you understand that. Okay, requests on number 3. I don't have time to talk about them all. Request. Dying to see what? Okay, so I heard A. So what is this? W of A would be the distance traveled after A seconds, and then if you multiply it by 2, it'd be just twice the distance that the car traveled in the first A seconds. Twice the distance the car traveled in the first A seconds would be that one. Okay, F. So let's look at this. What about just the numerator? Well, that relates to what we did here in D. This would be the distance traveled by the car over any half-second interval, starting at any time x. So this is the distance over a half-second interval, and we're to divide that by 1/2 second. What meaning would we get for that? So the total distance traveled over a half-second interval divided by 1/2 second. No. So this is a distance traveled over the corresponding time it took you to travel that distance. That's like a speed. That's going to be an average speed. Average speed over that 0.5 second time interval. Okay, so we'll make sure you bring your laptop with GC. We'll work with functions on GC on Wednesday. There will be a reading and a quiz, like always. Check Blackboard.